Now let me show you another way to represent a vector. It has to do with the horizontal and vertical components of the vector. Now this is going to seem really strange, but watch. If I take vector A, B, remember how this guy works. That just means that we're centered, our initial point is at 0, 0, and this thing finishes at some point A, comma, B. It doesn't necessarily have to be in the first quadrant, it could be all over the place. Another way to write this is AI plus B J. They are identical. Just think of I as being the horizontal and J as being the vertical components. There's no difference in the notation, so don't freak out. Now, I'm going to show you something. The nice thing about using these two ways to designate a vector is they become really easy to add. So check this out. Let's say that I have V equals, I don't know, 3 comma, let's go 3 comma negative 1. And let's say that W is equal to negative 1 comma 2. All right. Now let's look at these things real quick. We'll put them over here, put them on the Cartesian plane. I'm going to use black. All right. So here we go. 3. If I go over, I'm going to make these kind of big. 1, 2, 3, and down negative 1. Then that vector right there is going to be V, which is the same thing as 3 comma negative 1, or you may also be thinking that I can rewrite this as 3I minus 1j, right? They are identical, the same thing. And then if I go over negative 1 and up 2, that gets me right here, right? So this guy right here is negative 1 comma 2. Now if I want to add these guys, if I want to do V plus W, well, how's that work? Remember? I'm going to change my color here. I take this point right here. Remember, I take the tail of the second, attach it to the head of the first, right? And then I'm just going to go, what was it? It was over 1 and then up 2. And, whoops, sorry guys. I get that guy. All I did was move him over, right? This is still just W, as was this. And then the resulting vector is, I go from the tail of the first, tail to tail, head to head, and let's see what we got. Looks like we should have 2 comma 1, right? Well, watch. When they're in this component stage, do you agree that V plus W, I could almost line them up. I could go, that's going to be 3 comma negative 1 plus negative 1 comma 2. And when I add them, I get 3 plus negative 1 is 2, and negative 1 plus 2 is 1. Well, hush my mouth. I get the same vector. That's pretty cool, huh? Another way to think about it is if I do V plus W, this is going to be 3I minus 1j, right? And then plus negative 1I plus 2j. Now I just happen to stack these guys so it would be easy to add them. Look at what happens. I end up with 2I plus 1j, or another way to write that is just 2I plus j, which is exactly the same thing as 2 comma 1. There is no difference. That's a really nice way to work with them, isn't it? Not a whole lot to it. All right, now here's the question. How about if I want to know what the magnitude of V is? All right, that's a valid question, right? Well, what is the magnitude of this thing? If I go over 3 and down 1, I'm going to steal a little corner of this so I don't have to flip back and forth. I went over 3, I went over 1, 2, 3, and down 1, and I got, well, do you notice what I just made? Ooh, a badly drawn right triangle, right? Now this has, if I think of every vector as being in the form A comma B. Remember, this is the horizontal and this is the vertical. This can also be written as AI plus BJ, right? There's no difference between these, right? It's supposed to be a J. I don't know what happened over there. I had myself a glitch. So if it's a right triangle, all I got to do is, okay, it's the square root of 3 squared plus negative 1 squared, which is affectionately known as the square root of 10. Thank you for playing. In general, if I'm given V equals, let's call this A, B. Let's go A1, that's a 1 supposedly, and B1, which could be written as A1I plus B1j. And let's say that W was equal to, let's go A2 and B2. And this would just be A2i plus B2j. Well, think about it. What's the magnitude of V? Remember, horizontal and vertical, you got yourself a right triangle. This is just the square root of A1 squared plus B1 squared. Magnitude of W? Magnitude of W is equal to the square root of A2 squared plus B2 squared. That looks a little weird with all those 2's, doesn't it? How about V plus W? Well, it can be written like A1 plus A2, comma, B1 plus B2. Or it can be written as A1 plus A2, I plus B1 plus B2, J. Now you may say, Ripley, why are there these two different notations? Well, one is mathematical in context, and one has to do with physics. All right, so it's more of the physical. They're just different notations. Remember, different mathematicians took the same ideas and went off and played with them, and when they came back with different notations. You're going to use them interchangeably because they're very helpful. How about V minus W? Well, same thing, right? I'm just going to subtract the horizontal components, right? That's an A2, and then B1 minus B2, or I can do this as A1 minus A2I plus B1 minus B2J. That's it. There's nothing to it. Okay? Now, what if I do, let's say that I multiply through by a scalar. So what if I were to do, I don't know, I'm going to do beta because I got too many, my A's look too much like alphas. Let's say that I said beta times V. All right? Well, really what that is it's beta times A1 B1, right? Or beta times A1I plus B1J. So a way that I can think about this, and we've played with this before, messed around with some scalars, I just think of this as beta A1 and beta B1. And this is beta A1I plus beta B1J. In other words, you're just multiplying through by the scalar. That's literally what you're doing. All right? So that's all the notations in terms of how to deal with vectors. And really, we got this new useful notation, either this form right here or this form right here, the horizontal and the vertical components. This is also a component vector. They're written the same way. It's just a different notation to do the same thing. Okay?